imagination of art, where the brushstroke is guided by geometric principles and every sculpture embodies mathematical ideas. Hello, I'm Sayatana, and today I will show you that math and art have far more in common than what you think. But before that, let me explain you some keywords first, which are art and math. Art is the various creative activity such as painting, music, literature, and dancing. However, math is the study of number, quantity, shape, space, pattern, and relationship. Art and math are deeply connected. They both very creative. They both highly abstract in the way that they are. Now let's explore the captivating and intersections of art and math. So first we're going to talk about origins from ancient Greece to the Renaissance, which first we're going to talk about Polykleitos canons. So Polykleitos is a sculpture of ancient Greece, develops a set of ideal proportions for human body known as the canon. The canon applied the basic mathematical concept of Greek geometry such as radial proportions and symmetry, or we can say for it as a Greek for harmonious proportions. The harmonious proportions and balance among different parts of a figure. The canon focus on symmetry, the balancing of opposing body part and proportions, the relationship between different parts of the body. Next, we're going to talk about perspective and proportions. In math, perspective is a system for representing three-dimensional space on a two-dimensional surface, while proportion deals with the relationship between the size of different elements or quantity. On the other hand, in art, they work together to create the illusions of depth and spatial relationships on a two-dimensional surface. For example, like the artwork from Leonardo da Vinci, who is identified as one of the greatest painters in the history of Western art and is often credited as the founder of the High Renaissance. His artworks that are related to perspective and proportion have such as the Mona Lisa, the Annunciations, and the Last Supper. Next, we're going to talk about the golden ratio. The golden ratio, approximately 1.618, is a mathematical concept where the ratio of two quantities is equal to the ratio of their sum to the larger quantity. It often represented by the Greek letter pi and is closely related to the Fibonacci sequence. Artists use it to create balanced relationship between different parts of a work, often positioning subject along intersecting lines or placing elements within golden rectangle, spiral, or triangle, like the work of Leonardo da Vinci such as Mona Lisa and the Annunciation. Other work from other artists such as Girl and the Parrot Earring and the Great Wave. Now let's jump straight to another point, which is about planar symmetry. Planar symmetry refers to repeating pattern on a flat surface. In math, these are classified as wallpaper group which describe the symmetry present in a pattern, including translation, rotations, and reflections. These planes of symmetry act like a mirror and the object remains unchanged when reflect across it. For example, like the artwork detail of a Ming Dynasty portrait using a charmful hexagonal lattice pattern, Jali marble lattice at tomb of Salim Crispy, and also the Tupac Inca tunic from Peru. Let's jump straight to another point, which is about polyhedra. A polyhedra is a three-dimensional geometric solid with flat polygonal face, straight edge, and sharp corner or vertex. Examples include cubes, prisms, and pyramids. Study of polyhedra intersects with both mathematics and art, particularly in the realms of sculpture. The five regular polyhedra known as the Platonic solids are particularly noteworthy for their symmetry and historical significance. For example, the first print illustrations of Rhombicutahedrons by Leonardo da Vinci published in the Divina Proportionis in 1509. Now let's move to another point, which is about fractal dimension. Fractals are any of various extremely irregular curve or shape for which any suitably chosen part is similar in shape to given larger or smaller part when magnified or reduced to the same size. Now let's jump to another main point, which is about a complex relation. But first we're going to talk about mathematical tool for art. Mathematical concept and tool play a significant role in art, influencing various techniques and style. Geometry, perspective, symmetry, shape, color, and pattern are frequently used to create visual appealing and mathematically structured artwork. Now let's jump to another point, which is about stimuli to mathematical research. Art has sometimes stimulated the development of mathematics. For example, the Japanese paper folding art of origami used models, congruent pieces of paper such as square, and make them into polyhedra or trilling. For example, like about the stimulus to projective geometry, Alberti diagram showing a circle seen in perspective as an eclipse, and also a mathematical origami spring into action by Jeff Bainon made from a single paper rectangle. So now let's move to our last point for today, which is about allusion to oops art. So the black and white roofs that appear from spiral are in fact concentric circles. The mid-20th century oops art or optical art style of painting and graphics exploited such effects to create the impressions of movements and flashing or vibrating patterns seen in the work of artists such as Bridget Rayleigh, Sporros, Hermes, and Victor Varese. Lastly, let me give you a quick summary of what we covered today. Math gives structure and logic to art, and art gives math emotions and beauty. Together, they inspire both precision and wonder. That's all for my presentation today. Thank you for watching. Bye!